Okay, I think I'm going to do the rest of the question D, E, F together because D and F is just very short questions. Let's group them all together, okay? So part D say explain what is meant by enthalpy change of hydration. So hydration, this is like a definition question. It is when one mole of the gaseous ion is dissolved in such a large amount of water that any addition of water produces no further heat change. Okay, so basically the definition, every school will be slightly different. You can actually go to your school's lecture notes and put in your school's definition. That is also fine. Let's go on to part E. Yeah, so part E, they have given us table 1.2, okay, using data from this table and data booklet to calculate lattice energy. Okay, so lattice energy, pretty simple. You basically just need to take your elements, atomize, ionize, right? FAIL, remember this acronym, do the formation, atomization, ionization, then lattice energy. Okay, so let's check what do we have. Do we have formation? Yes, we do. This is your F already given to us. Atomization, do we have atomization? Actually we do. We even have for both, okay? Both atomization, both given, very nice. Do we have ionization? You have to get from the data booklet. So I'm just gonna do like a basic diagram for y'all to follow, right? You have strontium, which is a solid, and then you have chlorine gas. Okay, so you atomize it. Okay, so you get strontium gas, and you have two chlorine gas, right? And then after that, you will ionize it. The ionization, you need to do two, right? First and second IE. Okay, let me just put it in. Strontium 2 plus gaseous, and then you have 2 Cl minus gaseous. Okay, so the electrons that are lost from strontium, right, you will actually give it to chloride. Okay, so these two ions will actually give you strontium chloride solid. Okay, strontium chloride. Then of course you have to put in the delta H of formation for strontium chloride. Okay, so this one is delta H atomization times 2 for chlorine. This is delta H atomization for strontium. Atomization, and then you have first and second IE of strontium. Okay, maybe let me just add in this for strontium and for chlorine, and then these two are first and second EA. First and second EA for chlorine. Okay, did we have the EA? Let me see. We have. Oh, sorry, we only need one. My bad. First EA. Yes, we do have first EA. It's given to us in the question itself. Okay, then this obviously is your lattice energy, strontium chloride. Okay, so this is a very simple Born-Haber diagram, which you should have learned in your energetics. So basically, you just need to find all these values. I'm just going to highlight the values that you need from the data booklet, first and second IE for strontium. And I think, yeah, the rest is actually given. Okay, so if you use your Hess's law, right, you're gonna do this. You're gonna add all of this up. is equals to delta H formation. Okay, clockwise equals to anti-clockwise. All right, then you should be able to find your lattice energy here. Okay, so that is for E part 1. Let's move on to E part 2, right? Your answer actually should be negative 2146 kilojoules per mole. Okay, E part 2, using your answer to E part 1 minus 2146 and relevant data to calculate enthalpy change of solution. Okay, if you are unable to calculate, they want to give you the error carry forward, so they gave you a dummy value so that you can use it for calculation. Okay, so if you remember your delta H of solution, right? Delta H of solution is actually equals to negative lattice energy plus the sum of both delta H hydration, okay, or both cation and anion. Maybe you should split it up so that you will remember. Your cation, right, is minus 1480. I think this should be according to the table. Yes, no? 1480. Then hydration for chloride is negative 364. Negative 364. Okay, negative 364. We need to multiply by 2 times 2. Okay, so we add both of these up. And then you put in your negative lattice, negative 2146, yeah? Negative 2146. Okay, so you add the whole row up, you should get a value of minus 62 kilojoules per mole. Okay, so that is the enthalpy change of solution, so it is still negative feasible. Okay, but F, last question, is a suggest question. They say calcium fluoride is insoluble even though theoretical value of Gibbs free of solution is negative at 298 Kelvin. Suggest why is insoluble. So your Gibbs free energy, right, already takes into account delta H and delta S. Okay, so your thermodynamic factors are all taken into account already. So we probably need to use our kinetic. Okay, kinetics consideration. Maybe the EA is too high. Alright, so the reaction is actually too slow and it seems that calcium fluoride is insoluble. Alright, so that is it for D, E, and F.